Hello everyone! In this video, I will introduce you to the 7 basic tools of quality. These tools were introduced by Kaoru Ishikawa, a professor of engineering at the Tokyo University, who was the father of what we know the quality circles. Ishikawa sustained that 95% of the quality problems can be solved by these 7 fundamental tools. So, let's see what they are. Let's start with the flowchart. A flowchart is a visual tool that depicts the flow or sequence of steps in a process. It can be a manufacturing process, a purchasing process, engineering development process, and so many more. A flowchart also details the decisions, inputs, and outputs from each step of the process. It is important to use it because it will bring everyone in the room to the same understanding of what is happening in the process against what's supposed to be happening. Check sheet. A check sheet is a simple tool to collect, organize, and analyze data. Every problem you're trying to solve or any process you're trying to improve must be done with data, so you know where you started and where you want to go. The check sheet can be easily adaptable for a wide variety of purposes. You can use it to capture defect quantity per machine or shift, or you can capture continuous data, like the diameter of a pipe or the weight of a chip spec. It must include traceability data, like who is collecting the data, who is managing the equipment, when the data was collected, where in the process was collected, for giving some examples. Pareto Chart. A Pareto chart is a bar graph that shows which factors are more significant. The length of the bars represent frequency or cost and are arranged with the longest bar on the left and the shortest bar on the right. And it has a second component, a cumulative line that represents the total defects or costs when it reached the far right bar. A Pareto chart is based on an 80-20 rule, which tells that 80% of the defects are caused by 20% of the factors. This visual tool then will help you to identify what factors you must focus on to have the biggest impact to improve your process. Cause and effect diagram, also called Ishikawa diagram or fishbone diagram. The cause and effect diagram is another visual tool that will list all possible causes or potential factors that might be creating or at least contributing to a problem. There are 6 main categories that create the diagram: man, machine, materials, methods, measurement, and mother nature. All of these are also known as the 6 M's. It is recommended to involve a cross-functional team to create this diagram, so they can provide relevant input to each of the branches of the diagram. Because a problem can have many potential factors, we cannot focus on all of them. There is a subtool that accompanies the cause and effect diagram called support and refute table. This tool helps the team to decide, based on factual evidence, which factors are more likely to occur and focus on them. Scatter diagram. The scatter diagram is a graph that shows the relationship between two variables, normally an input variable versus an output variable. This visual tool shows how the input variable can affect an output to understand their dependencies, especially when you have multiple input variables. The strength of the relationship or dependency can be expressed with an statistical metric called correlation coefficient. It goes from a positive 1, that is a perfect positive correlation, to a -1, that is a perfect negative correlation. Right in the middle, we have 0. That means there is no correlation. And the fraction numbers on each side show some level of correlations between the variables. Histogram. The histogram is the most commonly used graph to show frequency distributions. or how often each different value in a set of data occurs. This visual tool will help you to understand the level of variation of your process, as well as patterns in your data depending on the type of distribution you have: a normal distribution, binomial distribution, exponential distribution, and others. A histogram is also the basis to calculate process capability. When you add process limits to the chart, now you can see how skewed or scattered your process is against those process limits. This will help you to decide which actions you should take to correct it. The last tool is the control chart. A control chart is a graph used to study how a process changes over time. In this type of chart, we will compare current data to the process control limits and understand whether the process variation is consistent or in control, or unpredictable, out of control, or affected by special causes of variation. Control charts are the basis of SPC, a statistical process control, that is widely used in the manufacturing industry to ensure their processes are in control to prevent defects. Control charts can provide good evidence for when you implement process improvements. If you capture data before the changes and data after the changes, the control limits will normally shrink, reflecting that the variation in the process is reduced. I hope you noticed that I went through the tools in a specific order. The reason is because these tools can fit into each other to help you to resolve a problem. Starting with the process flow, understanding in which step the problem is observed, collecting data from that process step with the check sheet, analyzing the data with a Pareto chart to define the more significant factors, uncovering all the possible causes with the cause and effect diagram, how variables can affect each other with the scatter plot, analyze the process behavior against the process limits with the histogram, and finally, ensure your process is in control after you apply the necessary actions to improve it. Of course, these tools can be used separately. It will depend on how complex your problem is. All right, now you know what are the 7 basic tools of quality. If you want to learn more about these tools, subscribe to my channel, follow my pages, or visit my website, learnwithcobb.com, where you can find more video tutorials like this. I'll see you in the next video.